Okay, so we have been looking at motion going side to side. Uh, and in order to figure out the time, the acceleration, the final velocity, initial velocity, and how far an object goes from side to side, we've been using these four equations. Now we're going to talk about what happens if we have an object and it's moving up and down. So we're going to talk about free fall. So free fall happens when an object, the only force acting on that object is gravity. So if something is falling or being thrown up and the only force acting on it is gravity, then it is said to be in free fall. But in the real world, we have air. So the air actually provides a force against that object moving up in the air, down the air too. So in free fall, technically there should be no air resistance. But in this class, we're often going to neglect air resistance. So neglect the force that is caused by air resistance because it's often very small anyway, so we're not going to worry about it. So when we have objects moving up and down, it's considered to be uniform accelerated motion. So basically that means that the acceleration is constant. And little g is considered the acceleration due to gravity. So little g is a in this case, and it's the acceleration due to gravity, and it's equal to this value. You need to know this value. It is 9.8 meters per second squared. So as objects fall, they are speeding to the ground with an acceleration of 9.8 meters per second squared. So the acceleration should be the same as when you start falling to the point where right before you hit the ground. So the acceleration will be the same. Velocity will change, but acceleration will be the same. And it is positive here. Little g is actually considered to be positive because as things move towards the ground, they're actually getting faster and faster. But in this class, when we solve problems, we're going to use it as a negative number. We're always just going to go ahead and say that acceleration due to gravity is negative. Now, does mass matter when we're talking about speed and acceleration? No. It will matter for force, but not for speed and acceleration. So, if we're looking at an object that's being thrown into the air, and we want to know what that looks like on a DT graph, well, if you have an object that's being thrown into the air, it's going to start going up in the air, and it's accelerating. It's accelerating at a rate of negative 9.8 meters per second squared. And eventually it hits a point where it can no longer go up and it starts to come back down. So it reaches a maximum height, okay, and then it starts to come back down. And the time it takes for it to go up will be the same as the time it takes for it to fall because the acceleration is constant. So at that maximum height, where you see that if you take the tangent line, so if you just draw a line right next to the curve, that slope will be 0. So since that slope is 0, and we know the slope is equal to velocity on a DT graph, the velocity will be 0 at that point as well. All right, so now let's look at doing a problem. So a ball is dropped from a height of 2 meters. What is the velocity before it strikes the ground? So we're going to solve it just like we've been solving the problems. First thing, we decide what it's asking for. So what is the velocity before it strikes the ground? So the ball is dropped first. So we're looking for the final velocity of the ball as it's falling. So right before it strikes the ground. The ball is dropped from a height of 2 meters. So 2 meters is a distance, so delta x. But in this case, because we're talking about up and down motion, it's delta y. So delta y is the same thing as delta x, it's just we're talking about up and down motion. So what is the velocity before it strikes the ground? Now it gives us more information, it's just implied. Because the ball is being dropped, we know acceleration is going to be negative 9.8. Because it's moving up and down, we know the acceleration. We also know something else. We know the initial velocity. Because the ball is being dropped, right before it was dropped, it had a velocity of 0. It was at rest. So we have three variables here. Now, because this is up and down motion, you need to do something extra. You need to make sure that your velocities and your delta x's and y's are negative if they need to be. So let's say that if we're going down in the downward direction, it's a negative value. If we're going up, it's going to be a positive value. Since the ball is being dropped and falls, that means that this displacement is negative. It starts at 2 and it falls to the ground, it falls to 0, so it's negative. So in these types of problems, check your velocities, VI and VF, and also and delta Y to see if they're negative or not. So if they're down, it's negative, it's going up, it's positive. All right, so we have three values, so now we're going to pick an equation. So right here, I'm looking for VF. So this first equation, I have one unknown so far. I have VI, I have acceleration, but I do not have time, so I cannot use the first equation because it has two unknown variables. VF and time are unknown, so I cannot use that equation. The second equation, I have delta Y. I do have VI, but I don't have time. So I cannot use this equation. Or I'm sorry, I do have delta Y. However, I'm solving for time here, and I could do that, but let's see if there's something easier. So the third equation, I do not have VF, but I have VI, I have acceleration, and I have delta x, so I'm going to use the third equation. So VF squared is equal to VI squared plus 2a delta x. So VF is unknown, VI is 0, acceleration is negative 9.8, and delta y is negative 2. So VF squared is equal to 0, so let's just go ahead and take that out. 2 times negative 9.8 times 2 should give me, I believe, 39.2. Yes, 39.2, it's positive because you have negative times a negative. All right, and now to finish it up, take the square root of both sides. So VF is going to be the square root of 39.2, which gives me 6.3 meters per second. Now, because we're going in the downward direction, it is actually negative. The calculator does not tell you that. The calculator only gives you one possible answer, but technically if I take negative 6.3 and I square it, I get 39.2. So if I take the square root of this number, it can be 6.3 or it could be negative 6.3. The calculator only shows you one possible answer, and since it is down, we're going to say it's negative. Okay, so let's look at the next part of this problem. All right, so we already have all four variables. We're looking for time here. So we're looking for time. We have four variables, so we can pretty much use any equation. And remember, we just solved for this, so we can use that value now. So let's look at the first equation. VF is known now. I have VI, I have acceleration, and I'm looking for time, so I can use that first equation. So VF is negative 6.36 or 6.4 roughly. VI is 0 plus the acceleration, which is negative 9.8 times t. So let's go ahead and take the 0 out since it's not going to affect anything. Technically, the right way to solve this would be to subtract 0, but that's not going to impact the other side, so we just take it out. Okay, so now, in order to solve, we're going to divide both sides by negative 9.8. So t is equal to that divided by 9.8, and you should get 0.64 seconds. So that's how long it takes for the ball to hit the ground. All right, so let's look at the position, velocity, and acceleration graphs in this case. So if we look at the dt graph for this, we know that we started at 2 meters, so we're not starting at 0, and we know that it's coming down to the ground, so we know we're coming back to the point of 0, which in this case will be the ground. So it's going to fall, and we know it's accelerating because it's falling, and we know that there is a constant acceleration, so we know the line is actually going to be curved. So a curved line on a dt graph means we have acceleration. So it's going to come down like that. So it's gradually going to come down. It's changing its position gradually as it comes closer and closer to the ground. It starts speeding up more and more because we're accelerating as time passes. So that's what the graph looks like for the dt graph. So for the vt graph, I know that I have a negative velocity because I have a negative slope. The line is going down. So remember, on a vt graph, if we have a negative velocity, it's going to be below the time axis. And we also know that there is a constant acceleration. Since we know that there is a constant acceleration, I should have a linear line. So it should look something like this. It is below the time axis because it's negative, because the slope here is negative, and it will be linear because we have a constant acceleration. So a linear line means the slope will be the same at every single point, and it should be because our acceleration is going to be constant. Okay, so let's look at the AT graph. So we know in this case that our acceleration, our slope here is negative, so we're going to have a negative acceleration here. So it's going to be negative 9.8. And we also know it's constant because we know acceleration due to gravity is constant, so it should be a horizontal line. And just ignore this line down here. So that's what our three graphs should look like if we had an object that fell from 2 meters. All right, so let's look at the next question, which is actually a pretty simple question. It says, how long would it take for the same ball to be thrown up 2 meters and then fall to the ground 2 meters? Well, we know it takes 0.64 seconds for the ball to fall from 2 meters. Since the acceleration is constant, it should take the same amount of time it took to fall to go up. So really, the total time that it would take to fall and come back, or for it to go up and then fall, would be 0.64 multiplied by 2. So it's 1.3 seconds roughly here. Because remember, acceleration is constant, so it takes the same amount of time to go up and come down from the same distance. Alright, so let's look at the next problem. And if I were you, I would pause the video and try to solve it on your own first, and then check to see that you understand it and you can do it correctly. Okay, so a ball is thrown straight down with a speed of 0.5 meters per second from a height of 4 meters. What is the speed of the ball after 0.70 seconds after the ball is released? So we're looking for the speed of the ball after the ball is released, so we're looking for VF. We know the ball is thrown straight down with a speed of 0.5, so VI is 0.5 meters per second. And remember, speed and velocity are the same thing as long as you're moving in a straight line. So in this case, it will be the same as the velocity. We know that the height that the ball was thrown at was 4 meters, so 4 meters is a distance, so delta x, or really delta y in this case, as we're moving up and down. Same difference. So we have that, and then we also have acceleration due to gravity is negative 9.8 meters per second. And it gives us a time, which is 0.70 seconds. So now, if I'm moving down, I'm going to say that it's negative. So my initial velocity is moving down, so it's negative, and my displacement was also negative. So now let's look at pretty much any equation. It should work because I've got 4 variables. So the first one, VF is unknown, but I have VI, I have acceleration, and I have time. So let's use that equation. So VF should be unknown. VI is going to be negative 0.5 plus the acceleration, which is negative 9.8, multiplied by my time, which is 0.70. So multiply it out first, then add. So you get negative 0.86 plus negative 0.5. So your final velocity should be 7.4, I believe. Yeah, so 7.36 or 7.4. All right, so let's do one more problem. And again, I would pause the video before I solve each problem to make sure that you're doing it correctly if I was at home watching these. So, all right, let's do the next problem. All right, a .25 kilogram baseball is thrown upwards with a speed of 30 meters per second. Neglect friction. What is the maximum height that the baseball reaches? So we know that mass is not going to impact speed or acceleration here, so we can just pretty much ignore that. It says, what is a maximum height? So height would be delta x or delta y. It tells you that it's thrown upwards with a speed of 30 meters per second. We also know acceleration due to gravity is negative 9.8. It's moving up and down, so we know the acceleration. Now it also tells you something else. It tells you that you reach a maximum height. So it's moving up, and then eventually it comes back down. So at this point, this is the maximum height. So we know that the final velocity should actually be 0. So you might want to write that down. A maximum height means the final velocity is 0. We have 3 variables, so now let's make sure that our values are correct. Since we're moving up, velocity should be positive, so VI is positive, and that looks good. So now we're going to pick an equation. So the first one, I have VF, I have VI, I have A. I could solve for time, but it's not asking for that, so let's look for something else. Delta X is unknown, so is time, so I cannot use that one at all. The third one says VF, I have that. I have VI, I have acceleration, and I'm looking for delta X, so I can use the third equation. So VF squared is equal to VI squared plus 2A delta X. VF squared is 0. VI is going to be 30 squared plus 2 times the acceleration of negative 9.8 times delta y or delta x. Either way, it's the same thing. So simplify, 0 is equal to 900 minus 19.6 delta y. So now you're going to subtract both sides from, or subtract 900 from both sides. So negative 900 is equal to negative 19.6 delta y. So now to solve, divide both sides by negative 19.6. Sorry, I'm running out of room here. So delta y, it should be 900 divided by 19.6. So you should get 45.9 meters. All right, so the main thing with these types of equations, and you will get a mix of equations that are not free fall and free fall. So if it's in free fall, meaning you're moving up and down, you know acceleration is negative 9.8, and you also need to check to see if your velocities and your delta y's or delta x's are negative. So if it's moving down, they're negative. If they're moving up, they are positive. Then you go through and you pick the equation. So you pick an equation that has one unknown variable. All right, and I will see you guys in class.